apologies for what happened in the last video. I think I got cut off, but continuing on from where we were. So we had just completed test number 32, and now we're on to test number 33. So we're still testing the route inspection optimization, and now we're checking that the optimization can handle graphs which have no direct connections or paths. So for example, graph B. Now if we have a look, if we think about what route inspection does, it finds a minimum path which traverses each edge at least once. So as long as we can traverse this edge, we can, we've solved our problem basically. And it doesn't matter which node we begin or start at. So if I come here, so if I input graph B, we have 3 nodes. AB is 5, AC is 0, and BC is 0. This is what we get. We are expecting the total cost to be 10 and the edges to revisit being AB, which is what we get. And if you think about it, that does make sense, because AB is literally our only edge. So we'd have to start at A or start at B, and then we'd have to cover the edge, and to go back to where we started from, we'd have to go through the edge again. So that's exactly what we want as an output. Another interesting thing I'd like to show you, which isn't part of my testing table, but I think it was worth, as I was going through the video, it came to my mind. If we just have 3 nodes with no connections between them, we can see that the system outputs that the length is 0 and no edges need to be revisited, and that shows that the length is 0. That just shows we can't retraverse anything because there are no edges. So I thought that was interesting to see how the system dealt with that. In fact, it's highly unlikely that the user enters 3 nodes and there isn't any connection. But if they do, then they are getting the correct outcome. But it's very unlikely, so it's not something we need to worry about too much. So obviously with other optimizations, for example these ones, for example prims, crisscross, or the shortest path ones, we deal with issues like that. But with route inspection, they sort of just say the length is 0. So that's fine. So how long has it been? It's been 2 minutes. So now we're moving on to the final, so last but not least, branch and bound. Now branch and bound aims to find the shortest path which visits each vertex only once. So we're going to check this for graph I, and this is what graph I looks like. It's very small, I do apologise for that. So if we see A to B is 10, A to C is 15, A to D is 20. So 10, 15, 20. So we have 4 nodes, 10, 15, 20. BC is 35, then we have 25, so BC is 35, BD is 25, CD is 30, I think that's the last one. Wonderful. So let's have a look at what we should have got. We should have got a cost of 80, we have a cost of 80, and a path of ABDCA, ABDCA. Wonderful, so that's a pass. I forgot to mention the other ones are also a pass, as we've discussed. I just forgot to update them. Okay. Now the last and final test is no direct connections. Unlike route inspection, if we have a graph that has no direct connections, we cannot even find a path that visits each vertex exactly once, because there's no way to access some vertices. So if I pass through graph B, which I think is what our test requires, yes. So 5, 0, 0, you can see that the graph is unconnected, hence no such route can be found. The system only supports connected graphs. This should really say branch and bound only supports connected graphs, because route inspection can support unconnected graphs. I will change that. Sorry for that error. However, overall it works, and we can see that we are having the result we expect to see. So that's nice. And we can also see it's given a reason. The graph is unconnected. So how long do we have left? We have 5 minutes. So that brings an end to the testing video. We've gone through all 35 tests. All of them work. Just one slight issue. The output for the branch unbound should say this branch unbound only supports connected graphs. So that's a very vague statement I've made there. I will change that. But other than that, thank you for listening. Thank you for going through this with me. And yeah, goodbye. Have a good day.